Hello learners, and welcome to your natural sciences lesson. So today we're going to be talking about the refraction of light. But before we start talking about it, did you know that refraction of light can produce mirages such as the appearance of water on hot freeways? Whenever you are in a car and driving on a hot freeway, on a distance you see that on the street there's water. That is actually the mirage that is caused by the refraction of light. So throughout this lesson, we're going to be talking about the refraction of light, how light is refracted, and also how do we then see the light that we are talking about. So before we get to that point, by the end of this lesson, these are the things that I want you to have learned or to have known by then. Number one, you need to be able to define refraction, be able to explain why light is refracted, and then be able to state the conditions of refraction. And then lastly, I want you to draw a ray diagram to show the refraction of a light ray. So in order for us to achieve these goals, in order for us to achieve those objectives that you have set, this is what you're going to be doing. We're going to be taking the main idea being the refraction of light, and then you're going to break it into two concepts where you're going to start by looking at how we see light, and then further after that, look in detail at the refraction of light. So we start by looking at how do we actually see the light, and then go then into detail and on the refraction of the light that we are talking about. So these are the things that you already know by now. Before even starting with this lesson, there are certain things that you already know by now. Now, those things are as follows, that number one, a ray diagram is a drawing that shows the path of light. So a ray diagram is that drawing that shows us the path taken by the light coming from the source and also into the surface, and then either being reflected or being refracted in this case. We also know that the white light that we see is made up of the 7 different colors of the spectrum that we are able to see. Remember the Roig beam. Now, they are arranged in terms of the increasing frequency. We also know that the reflected light that reaches our eyes and allows us to see the object. The reflected light, it is that light that allows us to see everything that we are seeing around us. It is because of that light that is reflected that we are able to see everything. So most surfaces reflect light. When light strikes a reflected surface, it can change direction. So if a light coming from the source bounces off the surface, remember the bouncing off light from a surface, that's called the reflection. So when that light bounces off the surface, it is going to change direction. If this is your surface, light coming from the source, remember if it's coming from the source, it's your incident ray. If it now strikes the surface and bounces off the surface, it becomes your reflected ray. So as you can see, the direction of this light ray has changed. Now, the last thing that we already know is that reflections of rippled water are not clear, but rather they are blurred because of the not so smooth surface that we find on rippled water. And when the surface is smooth, we are seeing a specular image or a clear image. If the surface is rough, then we are seeing a diffused image. That's why it is rather blurred. So, with what we know, can we then be able to answer the questions that we are having here? These are the multiple choice questions that we need to answer based on the information that we already have. So the question given to us says now, when all rays reflected on the rough or irregular surface are not parallel, the reflection is known as. So what we need to remember here about these two reflections is, we can either have a smooth surface or we can have a rough or irregular surface. Now, if substances, or rather in this case, if rays are reflected off a smooth surface, we are going to see a smooth image because those rays, when they are reflected, they will still be parallel to each other. So when this happens, the image that you're going to be seeing, or rather in this case, the reflection is going to be a specular image or a specular reflection. However, because we are talking about a rough or irregular surface, the rays coming from the source, they are parallel to each other. However, when they are reflected, they'll be going in all sorts of directions, so they will not be parallel to each other. So when the rays are coming from the source, they'll be reflected in all sorts of directions, So therefore, the image formed in this particular image is going to be a diffused reflection. So the answer is C. Then the next question is asking us that the angle between the normal and the incident ray is called the what? So we do know that we have a ray diagram. If we have a ray diagram, this is our surface. We have the angle, the ray of incident or the incident ray coming from the source being reflected off the surface, bounces off the surface. Now, we also have another line in between the two rays. That line is called our normal line, which helps us to measure the angles between the two rays, between the normal and the incident ray, and then between the normal and the reflected ray. So this angle between these two is called your angle of incidence. Now the angle between the reflected ray and the normal is called your the angle of reflection. So the angle between the normal and the incident ray is called the angle of incidence. So therefore that is going to be D. Our answer is D. So with what we know, we were able to answer these two questions that we were given. So throughout this lesson, there are certain words that you're going to be using to better explain the main idea being the refraction of light, how light is refracted. So we're going to be making use of words such as refraction, medium, normal line, and then the last two are going to be the angle of incidence and the angle of refraction. But then, before we start with the first concept and using these words, we're just going to quickly go for a short break, and I will see you just after this.